In today's video, we will be discussing the introduction to process industry, opportunities for electronics and instrumentation engineering students in process industry, the plant and process units, need for process control in process industry. So, what is process industry? So, as we know, the general term industry where raw materials are getting converted to finished goods, which will be for the mass market. In process industry, there involves a series of mechanical and or chemical operations on the raw materials. So the raw materials may pass through various stages: mixing, heating, cooling, filtering, storage, transportation, etc. to convert it to some finished goods. The operation in process industry can be continuous, batch, or sequential in nature. Now let us look into some of the main process industry. So when we say process industry, the first that is industry that is coming into our mind might be the oil and gas. In addition, there are n number of industry that can be clubbed as process industry: petrochemical industry, fertilizer, chemical, biochemical, cement, glass ceramics, pulp and paper, metal and alloys, power generation, waterways, water purification, microelectronics, electrochemical, heating, ventilation, and air conditioning in big malls and all, in trains, aeroplanes, green buildings, automotive. The list is very large. Process industry is providing a very good job opportunity for engineers. Let us look it for electronics and instrumentation engineers. What are the opportunities? In India, in public sector undertakings, there are many companies which is recruiting electronics and instrumentation engineering students for process control and related instrumentation jobs. They are Gas Authority of India Limited, Oil and Natural Gas Corporation, Indian Oil, Bharat Petroleum, Hindustan Petroleum, Oil India Limited, then Baba Atomic Research Center, Nuclear Power Corporation, Thermal Power Corporation, Electronics Corporation of India Limited, Engineers India Limited, Bharat Heavy Electricals Limited, Hindustan Aeronauticals Limited, Steel Authority, Aluminium Corporation, Fertilizers Limited. So the list is large. Here, the most of the recruitment is through gate examination. Some of them are having on-campus recruitment also. Now, when we look into the private industries, we have discussed many PSUs. So, when they recruit process engineers in their operations, definitely the private industries or counterparts of those PSUs will be requiring E&I students for the process industries. Some of the examples, just for namesake: Reliance Refineries, L&T, now Serum Institute of India, Dr. Reddy's Laboratories. Okay, these are pharmaceutical companies. Definitely in a pharmaceutical industry, the output need to be very precise. So the control and automation need to be very accurate. But in private industry, they usually depend upon the original equipment manufacturers who is providing them the full automation to their industry. So the original equipment manufacturers like ABB, Honeywell, Yokogawa, Siemens, GE, Emerson, and many Indian companies provide the solution for these private companies, and of course for PSUs also. So these OEMs are also a good opportunity for electronics and instrumentation engineers. Now coming back to process industry, the one of the main term that we hear again and again is plant. Okay, it is the whole factory which consists of many process units. We will see what is process units. So for example, when we consider a refinery is a plant in that sense that includes many processing like separation, then distillation, fractional distillation, heating, cooling, storage, reactions, reactors. So refinery is a very big process, big factory setup, and in that there are multiple process which we call it as processing units which are having clear cut functions. Now let us see some of the main process units in any plant. The one which is related with separation and purification process, and some of the examples are absorption and stripping, precipitation, extraction, mechanical separation like sedimentation, distillation. Mixture can be separated based on the volatility in a distillation column. Then reaction, fluid bed reactors, continuous stirred tank reactors, batch reactors, plug flow reactor, catalytic reactor, etc. Then mixing process. In order to mix different solutions using blenders, agitated vessels, etc. Then when we come to heat exchangers in an industry, there need to be a lot of heat transfers using equipments like condensers, reboilers, evaporators, heating and cooling vessels. Okay. Then sizing. The sizing can be to reduce the size as well as to increase the size. For reduction of size, we can use crushers, mills. For increasing the size, mixers, high shear mixers can be used. Storage and transportation is having a key role. For storage, we may be using tanks. For transportation, aided by pumps, pipings, and related fittings. Here we can see that, say, one process unit may get input from one or many other process unit. The output of one process unit may go to one process unit or go to more than one process unit. So it's a combination of process units create the entire plant. Now, if we just look at each process unit, it can be treated as a system. As I have mentioned, here it can be a single input, multiple input, or single output, or multiple output. Now let us look at some of the main characteristics of process industry. Here it is processing the raw materials. The raw materials specifications may change with respect to time. For example, a refinery, one of the main raw material is the crude. The crude content may change from the sourcing well. You might have heard about sweet crude and sour crude based on the composition or based on the content of sulfur in that particular crude. Then based on the ambient condition, based on the aging of the equipments, based on the raw materials, based on the utilities, the behavior of the plant may change with respect to time. Then the process industries are unique. Say say for example, the petroleum, the refinery that is producing petrol in India need to satisfy the BS6 norms. In Europe, they are having different norms. So each place to place, the industries will vary even if they are doing the same thing. So in many cases, we cannot copycat the designs. In one place it may work, in another place it may not work. So from the discussion, it's very clear that the process industries are having a very complex nature. In the long operating range, it will be non-linear. There will be many associated constraints, minimum level, maximum level of operations. Each process can be of single input, single output, or of multi input, multi output. Now, what is the main objective of any process industry? Definitely to provide finished goods to the mass market as well as to make profit. How? The profit can be maximized by maximizing the quantity and quality of the end product as well as by minimizing the quantity and cost of the utilities and raw materials. So these two points should be the key when we are designing any process industry. Now, what are the main requirements a plant or a process industry should satisfy during its operation? There will be some design goals. That is, it need to produce some finished goods. It have a minimum or it can have a maximum capacity. These are the design goals, main design goals. Then there will be technical and operational constraints. There will be pipelines which will be having constraints in flow. There will be pumps which will be having constraints in pumping capacity. There will be reactors which will be having holding capacity constraints. Then economic demands. The product specification. Recently, we may have seen, you may have noticed that the Indian government has changed the standard of petroleum that can be sold in the country. So definitely all the refineries, for example, need to update the standard of the output. Then there will be government regulations with respect to environment, regarding pollution, regarding sound. Then labor rules will be there, and also the equipment and personal safety is also need to be maintained. So as I have mentioned, the raw materials will be sourced from different places. Say, for example, if we are using mine, the output from the mine will, the composition of the output from the mine will change as the mine is going deeper and deeper. So the raw material specifications are changing. So these are some of the uh, requirements that a plant should satisfy during its operation. Now, what is process control? So since there is a term control is there, you will be able to answer this question. So when we are having control, we know that control is all about designing the input to a system such that the output will be in a desired value. So what is process control? Process control, it will give the complete tool that keep operation of a plant running within the specified limits while maintaining the product requirements satisfying various constraints. So the main task, as we have seen, it is a design and manipulate the inputs to the process to take the process output to the desired values. Now, how we can approach process control in an industry, in a plant? Since as you have seen, plant is a very big entity. So we have to approach it divide and conquer method. This is clearly explained in the next video where we will be discussing about the process control hierarchy. Now, what is the need for process control? The main needs are to satisfy the product specifications, operational constraints, safety, and environmental regulations. Along with that, we have to satisfy the technical, economical, and social conditions. What are the objectives? So, while we look at the need, we can create the objectives for process control to run the operations within the specified limits. It can be design specifications, there can be the specifications given by the government body, there can be the limitations due to constraints. Then, to minimize variability, the output product should not vary with respect to time. Okay, otherwise getting a market will be very difficult. If the output is having a lot of variations, so you have to assume that this output is going as a raw material to some other plant in most of the case. So if that quality is varying, then they will face the difficulty. Then the third thing is to maximize the profit. We have seen how to maximize the profit. So we can summarize the objective as first one as safety, second one with respect to quality, and third one with respect to optimization. How? How to get these objectives? By manipulating some process unit inputs in a feasible and an optimal way. Sometimes we may not be in a position to change the input to a process unit. So we have to look for inputs that can be manipulated. So that feasibility is also very important. At the same time, we have to select the inputs which are less costly. If you are changing inputs which are very costly, that we cannot say as an optimal operation. Now, what are the challenges in process control? So, in a chemical plant, as I have mentioned, there are multiple process units. So, there will be thousands of measurement and control loops associated with many sensors and actuators. We have to optimize between three things: total cost, speed, minimum disturbance. In most of the cases, these are quite opposite actions. When we try to minimize the cost, the speed will reduce. When you try to reduce the when we try to increase the speed, the disturbance in the output will increase. That means the variation in the output will increase. So we have to optimize all the three at the same time. So it's a big challenge. Then again, when we change one input, there can be a main impact in the output or more than one output. So that is also a bigger challenge. So we can conclude that manipulating the input variables of any process units are mostly a precise, demanding, and potentially hazardous activity. So when we look the process control from an overall plant-wide view, what are the main tasks? The main task is to design and manipulate the inputs to the process such that the process outputs are maintained at the desired values. Let us divide this task, or let us approach this task in a divide and conquer approach. So what are the steps that is required? First, we have to select the input variables which need to be manipulated or which can be manipulated. That variables we'll call it as manipulator variables that need to be identified from the large set of process inputs. Then we have to identify and select the control variables that need to be maintained at the desired value among various process outputs. Sometimes these process outputs may not be measurable. So in that case, we have to look for other outputs which can be measured, and these control variables can be calculated from these extra measurements. Then the control configuration structure. Once we choose the inputs and outputs, how to pair these input and outputs. In other words, whether we will be using a single controller to manipulate all the inputs at the same time, or whether we are using multiple controller to control each and every inputs. In that case, which input need to be paired with which output. Then selection of appropriate control algorithm like on off, PI, PID, MPC, etc. Once we choose the control algorithm, we have to optimize and tune the control algorithm to the best value. That is also a task. In the next video, we will be discussing process control hierarchy.